All right, so in the last video, we took a look at how to draw the Lewis dot structures for atoms and ions. Now we're going to look at how to draw the Lewis dot structures for ionic compounds. So in order for us to be able to understand how to draw a Lewis dot structure for ionic compounds, we need to understand what the charges of these ions are going to be. So since magnesium is in group 2, we know that it's going to have a charge of +2. Since chlorine is in group 17, we know it's going to have a charge of -1. So when we put these together, I'm going to end up with a +2 charge here and -1 charges here. So what that tells me is that I need 2 of these chloride ions in order to cancel out the charge of magnesium. So let's take a look at a super easy one first. Let's take a look at sodium chloride. So sodium, when we take a look at our periodic table, is in group 1. So I know that sodium's a metal, metals are losers, so it's going to lose an electron to form this ion. Okay, remember that let's look at the atom first. So its atom look like this, sodium with 1 electron. Well, it's going to lose that electron. So let's see here, do I have an eraser? I don't know. So it's going to lose this electron completely. And so now we're going to end up with just Na, put it in brackets, and give it a charge. And there's our Lewis dot structure for sodium ion. Now let's take a look at chloride. Okay, a chlorine atom has 1, 2, 3, 4, 5, 6, 7 electrons because it's in group 17. So what it's going to do is it's going to gain the electron that sodium lost. So sodium loses that electron, chlorine accepts that electron, and so now we put brackets around it. Since it gained an electron, it's going to get a charge of -1, and now I have my Lewis dot structure for sodium chloride. So this says a glimpse of the future, write the formula unit. A formula unit is just how many of each you have. So I've got 1 sodium, so I'm going to write sodium, 1 chloride, so I'm going to write chlorine, and so NaCl is the formula for the formula unit sodium chloride. Let's take a look at another one. This one's a little tricky down here. So I've got aluminum oxide. So aluminum is in group 13. So since it's in group 13, that tells me it's going to have 3 valence electrons. Since it's a metal, I know it's going to lose all 3 of those electrons. And so when it loses all 3 of those electrons, its Lewis dot structure is +3. Okay? Oxygen, let's take a look there. It's in group 16, so it's going to have 1, 2, 3, 4, 5, 6 valence electrons. So it's going to gain 2 electrons. So we're going to give it 1, 2 electrons. So since I gained 2 electrons, now my charge is -2. So now my question is, do my charges cancel out? No, of course they don't. So what do I need more of? I need more oxide ions because I've got +3 here and 2 minus here. Well, can I make an oxide ion that only has a -1 charge? I can't. Okay, and since I can't, all I can do is add an oxide that has a -2 charge. Well, guess what? Now my charges are still off. So I've got 4 minus charges and 3 positive charges. Since I have fewer positive charges, I have to add another aluminum ion. So let's add aluminum with a 3 plus charge. So now I've got 2 minus, 4 minus, and 6 plus. So now, as you're probably able to tell, I'm going to add 1 more oxide ion. All right, and there it is. Okay, now all of my charges cancel. I've got 6 minuses, 6 positives, and so this would be a valid Lewis dot structure for aluminum oxide. So when we are drawing this, we want to make sure that we put positive charges in between negative charges, and the reason for that is we don't want things to repel. Okay, so this would be an appropriate Lewis dot structure for aluminum oxide. So now, if I'm going to draw a formula unit, I'm going to look at my metals first. I've got 2 metals, so I'm going to put Al2. I've got 3 oxygens, so I'm going to put O3. And so this right here would be my chemical formula for aluminum oxide. Let's end this video with looking at some ionic compound properties. If I have an ionic compound, my properties are going to be as follows. I'm going to have a high melting point and a high boiling point. Okay, almost all of these are going to be solids at room temperature. Okay, they are brittle, meaning if you drop an ionic compound, it's not going to bend uh, or dent or anything like that. It's going to shatter. It says many, but not all, are soluble in water. We're going to look at that in a lot more detail when we get to our solubility unit. These are also non-conductive as solids, meaning that they don't conduct electricity when they're in their solid phase. However, when they are molten, meaning that they've been melted down, or when they're dissolved in water, these actually would be conductive, okay? And so the aqueous is the word that we would use to show that it is a dissolved substance. So that's it. We will get into covalent ionic compounds in the next video. Until then, stay strong. Shout out to fourth period. There you go. There we go.